Okay, so let's talk about putting it all together with respect to area and the area of irregular figures. Irregular figures. What am I talking about? Well, what I'm talking about is a situation like this where there is no formula for this particular shape. But if I envision this as a bunch of different rectangles put together, well, now I think we got something going on here. I don't know why the answer is sitting there all at the end, but let's show you how we get the answer to this one. So this figure is made up of three rectangles. For our purposes, for now, we can get either rectangles or triangles and put them together in a figure to find the area. So I basically have three types of rectangles here. Two happen to be squares, but I have one on the upper left, one on the upper right, and as I drew this border across, it separated into this really big rectangle down below. So my first move was to draw this line, which created and separated the irregular area into two regular areas. And again, I have one square up on the left, or type of rectangle, and another on the right, and then a big rectangle on the bottom. More traditional looking. So if I compute the area of the rectangle in the upper left, and then the upper right, and then the bottom, and add them all up, the total area will be the sum of the areas of those rectangles. So upper left first. That'll be 5 meters times 5 meters, which is 25 meters squared. And that's the same exact size as the figure on the right. How do I know that? Well, what I can tell is that these figures are the same size. It was 3 meters in the middle, and it was 13 meters altogether. So that means that 10 meters has to be split evenly. You also have the 5 meters up top and the 5 meters on the bottom. The fact that this is 5 meters here and the whole side is 10 meters means that this piece down below is 5 meters. So the upper right is 5 meters times 5 meters, which is 25 meters squared. And then the big rectangle is going to be, now remember, this piece over here is 5. 13 times 5, sorry, the base here is 13. So 13 times 5 is 65. And then if I add them all up, the 25, the 25, and the 65, all meters squared because they're all areas, then I come up with a total of 115 square meters. Okay, so once again, the total area is the sum of the areas of the rectangles. So I do the upper left rectangle, the upper right rectangle, the big bottom rectangle, I add them all up, and I get the 115 meters squared. Okay, you try this one. Stop and start. Okay, so this one is made up of a rectangle, almost looks like a square, but it's not quite, it's 8 by 9, and then a triangle. And remember, these sides of the rectangle across from each other, the opposite sides, they are going to be equal. So the area of the square will be 8 centimeters. Oh, I wrote meters, sorry. 8 centimeters times 9 centimeters, which is 72. It should say centimeters squared. And then for the rectangle, it's 8 meters or centimeters times 6 centimeters, which is 24 centimeters squared. And then if I add up, because remember, it's a half, the base times height. So half of 8 times 6 is 24. And then the total area will be the 72 on the left, the 24 on the right, the triangle part, add them up, and I get 96. Here's another one for you to try. Okay, so what I want to do now is, again, it's an L-shaped figure. I need to create two different rectangles, and whichever way I draw the line, it's going to work as long as I do the line properly. There's my line. So I've created a tall rectangle on the left and a flat rectangle on the right, a wide one, if you will. So the total area will be the area of the two rectangles added up, the sum of those areas. So in this tall one on the left, it's going to be a 6 meter height times a 4 meter width. So 6 meters times 4 meters is 24 meters squared. And this bottom one is going to be 1. How do I know this green line is 1? Because from here to here is 5. And the whole length is 6. So that leaves 1 for here. So 1 times 10 is 10 meters squared. And then I just add 24 meters squared plus 10 meters squared is 34 meters squared. Okay? All right, so that's some area of irregular figure work. Now let's work a little bit on circumference and area of a circle. And once I put that circumference and area of a circle together, then what I will do is, once I put those two together, the circumference and area parts, that on our next lesson, we'll add some of those into irregular figures. So, the formula for circumference is pi times diameter. C is circumference, D is diameter. And the formula for area is pi r squared. A is area, as opposed to the C being circumference, and R being radius. So the diameter in bluish purple here goes all the way across, and the R, the radius, goes halfway across. So that leaves me with this saying that I was taught by a student of mine, Katie Heisenbuttel, years ago. She said that she had learned this. This was going back about 30 years ago. Cherry pie is delicious, apple pies. I wrote it that way because pie is spelled P-I when in math, are too. So cherry pie is delicious, apple pies are too. Ready? Cherry pie is delicious, C pi D. Apple pies are too, A equals pi r squared. So that's the way to remember the two formulas. Cherry pie is delicious, apple pies are too. Okay, so now let's take a problem, and if the diameter is 10 inches, not in, 10 inches, and using 3.1416 for pi, find the circumference and the area. Go ahead, give them a shot, and I'll go over them with you in just a minute. Okay, so as far as circumference goes, cherry pie is delicious. So circumference is pi times 10 inches. Now, this is when, let's just cut to the chase here. So the circumference is 10 pi inches. And this is where the way they want the answer can affect what you put down. Now, most of the work we do is multiple choice. Most of the work many classes do is multiple choice. So you could just see, did the choices have a pi in it? But sometimes the directions will ask you to substitute 3.14 or 3.1416 for pi. Now, pi does not exactly equal 3.14, nor does it exactly equal 3.1416. Pi is an irrational number that goes on forever and ever and ever with that decimal, and it never repeats. But 3.14 and 3.146, those are really close approximations, as is 22 over 7. So when we need to do the work and we say, well, we want it as a decimal to the nearest tenth or whatever, I substitute in this case, I did 3.1416 for pi, and 10 pi means 10 times pi. So 10 times 3.1416 is 31.416. And then I just round off to wherever they tell me to round off. Okay? So, summarizing, cherry pie is delicious. So C is pi times the diameter. Remember, the diameter goes all the way across, and it says in the problem that the diameter is 10. So that's 10 times pi. And if I want to convert to a decimal, I substitute 3.1416 for pi, like it says to do in the problem. Sometimes it'll say 3.14. Now, as far as area goes, the big difference is the circumference formula uses a D for diameter. The area formula uses an R for radius. So the first thing I have to do is I have to say, okay, area is pi r squared, or apple pies are too, but then the radius is 5 inches. So it's not 10 like the last time. 10 was the diameter. The radius is 5. So I put a 5 inches in there. I square it. I get 25 pi inches. And if they tell me to leave it in terms of pi, I'm done. If not, then I do 3.1416 for pi. And 25 times 3.1416 is 78.54. Okay? All right. So here are 3 for you to do. Go ahead. In each case, you do circumference, then area. Circumference, then area. Circumference, then area. So let's just do number 1, the circumference and area, and then we'll stop. And then we'll go into 2 and 3. Okay, so In this case, notice that because the radius is 8.2, the diameter is 16.4. So we have to be able to convert back and forth between them, okay? Now, the circumference formula calls for the diameter, which is why I needed to do that right away. So the circumference will be pi times that diameter, which is 16.4, which is 16.4 pi. We traditionally put the 16.4 in front like a coefficient. And even though the pi is not a variable, we kind of treat it like one, but it has a specific value. If I want to round to the nearest tenth, I plug in 3.14, and 16.4 times 3.14 gives me 51.5 when rounded off. Now, as far as the area goes, well, that's a different formula. That's pi r squared. So remember, cherry pie is delicious. Apple pies are too. So area is pi times the radius, which is what they gave you in the picture, 8.2 squared. So that would be 67.24 pi if I left the answer in terms of pi. And if I convert to the nearest tenth, then I multiply by 3.14 and I get 211.2. Okay, let's have you try the next one, number 2, circumference and area. Then we'll go over it. Okay, final thoughts. Okay. Now, in this case, you can see that the diameter is 12.5, which is great for the circumference formula, but it doesn't help us with the area formula. So it's worth noting that the radius is half of that, which is 6.25. So the circumference, and let's just get out of the way here for the last one. If the radius is 26, then the diameter would be 52. It's double the radius. Remember, radius goes halfway across, diameter goes all the way across, so I have to add in or double another 26. All right, so circumference is pi times diameter. Diameter is 12.5, so it's just 12.5 times pi feet. And if I want to convert to nearest tenth, I plug in a 3.14 for pi, I multiply because there's no symbol in between, and I come up with 39.3 feet. As far as the area goes, it's pi r squared. So that's pi times 6.25 feet squared, which is 39.0625 pi. And if I wanted to round that to the nearest tenth, 39.0625 times 3.14, that's good enough, is going to be 122.7 feet. Okay, number 3. Go ahead. Okay, so we did area first this time. That's strange. Okay, so let's do the area. Area is pi r squared, so the area is pi times 26 squared, which is 676 pi centimeters. And if I put in 3.14 for it, for pi, I get 2122.6 centimeters. Now, as far as the circumference goes, that's pi times diameter, which is pi times the whole 52 centimeters all the way across, which is 52 pi centimeters. And then plugging in the 3.14 for pi, I get 163.4 centimeters. So our summary. First, if you get a probability of or, you add. If you get a probability of and, you multiply. Next, any guaranteed event has a probability of 1. So for certain events, like winning and losing in the playoffs or getting a foul shot in or not in, the probability of A plus the probability of not A is 1. The perimeter is the distance around. It's the sum of the sides. Area measures how much is inside of a two-dimensional shape. So the circumference is the perimeter of a circle, if you're dealing with a circle. And remember the saying, catchy little saying that Katie Heisenbuttle taught me, cherry pie is delicious. Apple pies are too. Have a great day.